this is an area that needs so much collaboration. There is no energy transition without mining. The world needs more metals for energy, for automotive, for data and AI than we've ever needed at any other time in human history. But the mining sector itself is extremely energy intensive, and also a lot of mines are in high water stressed areas, so are competing with local communities for drinking water and agriculture. So the mining sector has this real challenge where it needs to grow and create this output that's required for the decarbonisation agenda, but it also needs to also reduce its own footprint at the same time, reduce energy and use water. And that's not just about capacity constraints or costs for the miners, it's about the very licence to operate for the mining sector. And because it's such an integrated challenge, no one player can solve that on their own. That needs governments, it needs policymakers, financial community, but it needs also the technology providers into the sector and right through to the end users of the metals, the automotive companies, the energy companies, the data and AI centres, to really align on what are the drivers of change. As a global technology provider into the mining sector, by far our biggest environmental impact is our products in use on our customers' sites. If we talk about carbon, 98% of our carbon footprint is our products on our customer site. So the most material strategic thing we can do to align with COP30's ambition is to help our customers deliver their transition strategy around climate. And that requires us innovating technologies to help our customers transform and materially change to use less energy, use less water, and to create less waste. If you take those issues of energy and water, then energy is quite concentrated where it's used in a mine site. So about 35% of an average mine site's energy is used in crushing rocks, a process called comminution. But you can do it a different way. If you think about applying different proven technologies and taking different mechanical processes, different chemical processes, and use new processes that in themselves would be much more efficient, but add them together, you get much more significant material transformational changes. So for example, if you take different crushers like high pressure grinding rolls who crush between rollers, crush the rock, and then combine it with different separation technologies like vertical stilled mills and coarse particle flotation, you can end up saving up to 40% energy and up to 50% carbon compared to traditional tumbling mills. If you think about water, water is extremely complicated. It's very dependent on the locality, around the geography and the geology of a particular mine site. And as such, technology tends to be really specific for that individual mine site. But the thing that we're finding really interesting and innovating around now is you can simplify it. So you can classify mine sites into certain geologies, so these archetypes that are just a handful of numbers of archetypes for mines. You can then add on a layer of geography, so what are the weather conditions in that mine site now and in the future? And then lastly, you can then start thinking about what are the KPIs you're really trying to solve for. Is it volume of water? Is it quality of water? Is it quantity? And if you layer those three together, you can start thinking about technology at a much higher strategic level. So rather than designing for a particular mine site, you can elevate the conversation. And why is that valuable? Well, if you can elevate to a strategic conversation, you can have much more strategic view about what's best available technology for types of mine rather than really trying to design for every single mine specifically. And you can actually drive much bigger systems change throughout the mine and throughout the mining sector. Secondly, if you're really thinking about best available technology, then you are also giving yourself better climate resilience because you're thinking about different and future weather conditions that might impact and how different technology might be required for those different weather conditions. And last but not least, if you have thought about best available technology and can really evaluate it very robustly, and you're also thinking about climate resilience, then there's a potential that you might be able to unlock new costs of capital as well, sources of capital. So those are the areas where we're seeing miners really show a lot of interest around how you can materially drive down both energy and water use by taking proven technologies and think about differently about how you apply them.